Hello everyone. So today we are going to work on how to implement proning for the third person character. So here you can see the character is in proning mode, and when I press Alt it stands up. So the smoothly capsule size is also changed, and for proning and standing up, and also there are animations to stand up and go to prone. And other than that, I have also worked on here. The character does not go through the walls. It stops even though the full body is not encapsulated by the capsule. It still can detect when it's trying to go through walls, and it prevents it. So if I press A here, so it stops. So yeah, this is what we are going to work on today. Oh, also notice in here when we try to rotate or change the directions, it's not as fast as when we are walking. So here when we walk, we can quickly turn, but in the proning we don't. So yeah, let's see how to do those things today. Okay, so here I have already imported these animations. I have prone in forward animation and prone idle animation and prone to stand and stand to prone. So only 4 animations. Now I'm gonna create a blend space to be used when the character is in proning mode. So for that, we should create a 1D blend space. So for that, let's go back to the mesh and right click, create blend space 1D. Right, you got it. I'll name it BSP 1D. And I'll move it to the place where I had the prone animations here. Open it. On the asset details, on the horizontal axis, what's the speed we have here? We have 500 in walk run cycles, so maybe for prone, let's have something like 100, which is already the default value. I'll name it forward, and here at the 0 I'll add prone idle, and at 100 I'll add prone forward. Okay, now save. Now go to animation blueprint of the mannequin and 𝐒𝐴𝐵𝐵𝐿. So this is a child of 𝐒𝐴𝐵𝐵 mannequin. So there we can see the anim graph. So I'll drag and drop BSP 1D prone here. So this control rig and everything matters for the walking part, so we don't really need to have these things activated for the proning. We would run into problems with that, especially regarding the foot placement. So therefore I'll add blend space 1D after that. Here let's have a blend poses by tool, and as the true pose I'll connect BSP 1D Pro, and as the false pose I'll connect the walking one, and I'll promote this to a variable called prone, and I'll connect this ground speed, which is already calculated for the walking movement, to this forward axis value of the blend space. Okay, so now to keep things simpler, let me go here. So you can actually set up an input, but I'll just simply use Alt left Alt as the input, just to save time in the tutorial. And then when I press Alt, the character should go to proning mode. For that, we need a way to set this proning to true. And when we go back from proning to standing, we should set it false. To easily set that, in the begin play, let's get a reference to mesh. Set get animators and cast to ABP many, and let's promote this to a variable as ABP many. Right. Now here when we press let's have a flip-flop so that we can switch prone to standing and standing to prone. So get the ABP many, set proning to true here, and set proning to false in the B. So if you don't know what flip-flop is, when we execute this node first, it will execute A, in the next time it will execute B, and if you call it again, it will execute A. So like one after the other. So right, now let's see. If I press Alt, it goes to the proning mode, which is quick, and also we can move, and also it is fast. So we have to fix those things. And also you might notice, like if I go here, I can go somewhat through the wall as well. We need to fix that too. Also we need to use the animations that changes from standing to proning as well. Okay, first let's add the animations. Here, stand to prone and prone to stand. Right, I will create an anim montage for both, and then in order to play animation montages, we already can, but it's before the control rig, so I'll add it after the control rig. Sorry, not control rig, after this switching. Otherwise, when we are in the proning mode, we will not be able to play animations. Right, now here I'll play it this way. Get the mesh, play anim montage, play montage, and so this is where we start to prone. So stand to prone, and here same node but prone to stand. Okay, now this should work, but we should still have some problems. If I press Alt, see, so, and also if I press Alt, if I bash Alt, this happens, which is crazy. Okay, so I'll move this node actually. Here afterwards. So not exactly in the at the end. Let's just have some delay. Like, what's the length of this animation? .6. Okay. So then 0.6. That should be enough. Now let's result. Wait, why did it stand up? Oh, I haven't cut it. Okay. Now it should work. Right. We see some poppy. I wonder if I increase this blend in and out times. Out time. That should be dampened. See? Yeah. See? Nice. I'll do the same to this one also. Okay. And the animations look like pointing a gun because these are from 𝐒𝐻𝐚𝐧𝐬, so that's the only animation available, right? And the movement part. Now let's one more thing. If I press Alt while in the middle, this goes crazy. So to prevent that, we can do this. Here, let's have the do once node, and then after this, whatever this is executed, add a reroute node, this or this. For both we need it, and then we can add another reroute node here. Reset. Right. Now we will not be able to bash it continuously. Okay. Now the animation setup is complete. Next step is changing the movement speed and the capsule size. So to clearly understand this, I'll remove this hidden in game boolean for the capsule. So when you press Alt, you see the character is like this, but the capsule stands tall, which doesn't look good because that will, even if we are crawling, that will prevent us from crawling through the small spaces. So we can, as we prone, we can change the capsule size. For that, let's first test it. Let me add a reroute node here and collapse it. Set capsule prone. For prone. Now here, let me get a reference to the capsule and set half height. What is the half height at the moment? 90. So I'll do something like not 30. Let's say, yeah, let's try 30 and see what happens. Okay, now the character is through the capsule. So in order to compensate for that, we have to set the offset of the mesh. So at the moment it's minus 90, which is roughly same as the half height. So set not local, relative. Location. Set relative location. So this would cause the mesh to snap. We will fix it in a bit, but first let's get the numbers right. So get half height and multiply it by minus 0.5. Hold it here. Right, it's not correct. So it should be more over. So let me just discard this. Let's manually set about minus 35. Yeah, that value seems correct. So we need to have the same thing. For walking as well. Set capsule for okay. So now we need to set it back to the previous value, which is actually was it 89? That's 90. It's 90, but the mesh offset is 89. So oh, actually it's not a half. I miscalculated it before the first time. Right, no, okay, and it works, but also it snaps. We need to prevent that too. So for that, here, how to go about it? Okay, let's connect it like this. And we can add a timeline here. Timeline. Play from start. So let's add. I'll make it 1 second. And let's add a float track. I'll call it time. Initially it would be 1. At the end it would be, so initially it would be 0. At the end it would be 1. It has to be 1. Right. This must be 0. Okay, now here we have the time. So these are the values we need to have. Half height, we need to set half height to 30 and this one offset to minus 35 at the end of this timeline. So therefore we can multiply this with 30 and connect, and similarly multiply this with minus 35 and connect here. Right. Oh, one more thing, I don't think I connected. Okay, and let's connect the output when we are finished. Didn't work as expected. Oh, sorry. This should be minus 35, not 1. Still not correct. Oh, sorry. I forgot one thing very important. Because at the beginning, the half height is not 0. It is 90. So therefore, we have to lerp it. No. This. Lerp. 90 to 30. With this alpha. Similarly, lerp minus 89 to minus 35 with this alpha. Yeah, now it's smooth. We need to fix the standard part as well. Can we rename this timeline? Oh. Okay. Can you copy this? Timeline from get no. Okay, copy. Timeline from this. Right, so this also has the same values. Now, just like before, we can play from the start. And in update, now this time we have to lerp same as before, but on the other way. Or fail actually. We could copy the same thing. And play it from reverse, play it in reverse. Instead of play from the start, we could reverse from end. That would do the same thing. Okay. Now, unfinished output. Right, that's it. Result. It's going to the front and standing up smoothly. Nice. One more thing, we need to set the speed. So to set the speed, character moment, set I think max walk speed. Set max walk speed. So when proning it should be 100, but by default I think it's 500. Yeah, 500. So when it's back to not here, copy. When it's back on standing, the speed should be returned back to 500. Alright, now let's see. Let's still do kind of snaps. Let's try 50. Oh, when we set it 50, we need to set this value also 50. Otherwise, it won't match. Wait. Oh, since I set it to 50, the animation lost. So let's first move it to 50, then maximum value of 50. Alright, now let's see. That seems more fitting, but this snapping is not good. In the movement component, if I reduce this acceleration while proning, this acceleration and also this one, braking deceleration, if I modify this, we should be able to prevent that snapping effect. So how should we do it? Maybe we need more space here. Set from parameters. Okay, max walk speed set, and set max acceleration to, let's say, 200. And deceleration. How to say deceleration? It's in moment walking. Making deceleration. For walking. That's also, let's set to 200. Maybe that could cause the character to slide. Oh no, it seems fine. Yeah, that seems fine. And one more thing, we need to reset these values. So same as before, let me just duplicate this and do this because everything is here. Max acceleration is 1500 and this is 2000. Okay, now let's see. Works fine. Pronin seems also fine. And the next thing we want to resolve is the issue that the head going through the wall. So to resolve that, and also this rotation speed, this seems quite fast, but that may be a problem for another day. But maybe we can just fix it by changing the rotation rate. Where is it? It's in character movement rotation settings. Here. By default it's 500. So we can set that also. Rotation rate. Oh, this is not prone. Set work parameters. For proning, we need to set it to a most lower value. So I guess something like, I have no idea, let's try 50 and see. Oh yeah, that seems more like it. Okay, now to prevent head going through this, that's the next part. For that, let's take a look at the movement inputs. Left, right, and forward. Okay, so here, this is the direction in forward movement. This is the direction that we apply the force movement input. Copy that. Well, no need to copy. Let's do a line trace by channel. And get this inside and this value outside. So I'm just setting up a function. Collapse to function. Can move. Can move. It has to sound like a question, and I'll make it a PO function. And this is direction. So this is simply a check to see if we can move in this direction. And since we need to do a line trace here, we don't really have to do it always unless the character is actually trying to move. So we can do a branch first to check if the character is trying to move. So by checking if this is not equal to 0. So if this is not equal to 0, that means we are trying to move forward. I think we should collapse this. Otherwise this should be messy. Move forward. Same thing here. Move sides. Okay. Now let's fix this. Yeah, as I said, first we need to check if we are trying to move, and if yes, we need to know if we are proning. So let's have another variable called proning in our blueprint. And we need to set it to false when we stand up. No need to really connect this. Even though we connect it, it wouldn't be a problem because both are going to be true. Right now, here we also, let's have another branch to check if we can move. Alright, so now if we are proning, we need to check. If we are not proning, we can simply move. So how do we check if we can move? So we have the direction, and also let's get actor location, and from actor location, and also we have the direction. Let's multiply this with float, maybe 80 degrees. We can change it and add to this location. So the starting point of the trace is going to be actor location, then actor location plus 80 units along the direction. So we are going to do a trace, and if something hits, we can't move. So actually we should return not of this. Not if something hit, we can't move. If anything is not hitting, we can move. That's what I'm doing here. Let's add a debug type so we can check it. See, now the character is not moving its head into the, if I press left or right, it still does, but for the forward it's not. Now let's do the same thing to the forward as well. Copy this, so not forward, to the side. Can move. Direction is this. Okay. Something is wrong. Yeah, this should exit regardless of what happens inside. So otherwise move forward will not be processed. Alright, now let's see. Oh. Okay, it's not hitting, and if I press right, it can move, and if I press right again, it does hits again. It can still go through. Oh, wait, we have a problem. When we press move left, that means A, it still check right. So we need to multiply the direction here. Otherwise cannot work correctly. So now I'm pressing D, so right is checked. Now I'm pressing A, left is checked. Okay, and similarly I think I need to do the same thing for move forward as well. Okay, now let's see. Here, if I press A, D, now it's not going through the wall. If I press A, it turns, but see, it's blocking. Great, so it's not going through any objects anymore. When we do the crash right next to a wall, it still goes through sometimes, but yeah, maybe I will not address it today because it has already taken 40 minutes. So that's all for today, and thanks for watching. As always, project files will be available for the download in the Patreon page. Link would be in the description below. And if you like to support my work, you can get the membership of the Patreon Club. See you in another episode. Goodbye.